Design tips for injection moulding. Injection moulding is a versatile process that requires some key design considerations. In this video, we provide some important points to consider when designing for injection moulding. 1. Carefully choose suitable materials for your design. Thermoplastic resins used for injection moulding fall into two categories that both have their own advantages and disadvantages. Semi-crystalline thermoplastics are excellent for bearing, wear and structural applications, have good chemical and electrical resistance, as well as lower coefficient of friction. However, they are difficult to bond with adhesives and their impact resistance is average. Amorphous thermoplastics bond well with adhesives, have high dimensional stability and good impact resistance. However, they have low resistance to fatigue and stress cracking. These resins can be categorized as low-cost commodity resins, medium-cost engineering resins, and high-cost high-performance or specialty resins. 2. Take into account the part tolerance. Tolerances are affected by the shrinkage that occurs during the cooling process. Amorphous materials, like PLA, generally have tighter tolerances than semi-crystalline material like PEEK. Tight tolerances make production more expensive, but they may be necessary for your part to fit or function properly, especially if it is used in an assembly. We recommend contacting your supplier at the design stage to discuss the tolerance standards that they use. For example, DIN 16901 contains a general tolerance table as a reference for different materials. If your supplier uses the standard and you need tighter tolerances or other standards, they will ask you to provide 2D drawings. 3. Choose the right wall thickness. There are a few key points to consider to ensure you choose the right wall thickness. Thinner walls shorten the cycle time and lower the cost of your part. For lots of applications, a wall thickness of 1.5 to 2.5 millimeters is sufficient, but you can also refer to recommended wall thicknesses for different materials. Unlike CNC machined parts, plastic injection molded parts benefit from a consistent wall thickness. If a part is thicker in one section than another, a sink mark will appear at that location. Non-uniform wall thicknesses also lead to warping, as these walls cool and shrink at different rates. If you require a non-uniform thickness, the change in thickness should not exceed 15% of the nominal wall thickness and should always have a smooth or taper transition to achieve a high-quality part. 4. Add draft angles to your design. Using injection moulding for a part with vertical walls will cause it to get stuck as the part contracts when it cools, which could damage the ejector pins and even the mold. Design the walls of parts with a slight slant to avoid this problem. This slanting is called draft. Different surfaces require varying draft angles. Textured surfaces require the biggest draft angles. Some common surfaces found in injection moulding and their minimum draft angles are as follows. 5. Add ribs and gussets to certain parts. We recommend adding ribs and gussets to parts instead of increasing their thickness to strengthen them. They also help to eliminate cosmetic defects like warping, sink and voids. However, if designed incorrectly, this can lead to the permanent bending of some sections. The warping can be reduced by keeping the rib thickness between 50 to 60% of the thickness of the wall it is attached to. 6. Add radii and fillets to your part design. Since molds are CNC machined out of either aluminium or steel, sharp internal corners are difficult to create and significantly increase the cost of mold production. In addition, sharp corners within the mold can weaken the resulting part, as molten plastic is forced to flow across or fill in a sharp corner. That's why we recommend using your CAD system's filleting tool to add a fillet and create smooth transitions between the walls and features of your parts. It will improve the material flow, the part's structural integrity, distribute the stress on the corner and simplify part ejection. The only place on your parts where sharp corners are naturally created is at the parting surface or other shut-off surfaces. Add internal radii at least 0.5 times the thickness of the adjacent wall and external radii 1.5 times the size. 7. Avoid undercuts and provide slots where possible. Complex part geometries and parts with snap fittings have undercuts that prevent the part from ejecting from the mold. Often these undercuts are formed using a mechanism called a slider or lifter. This is a movable mold part that slides inside it once it is closed and slides out before it opens. This mechanism adds complexity and increases mold costs. In the case of a simple cantilever snap, you can avoid this expense by either moving the snaps to the outside of the part if possible, or providing a small slot or pass-through core at the base of the cantilever. This will enable the injection mold to open and the part to eject without sticking in the mold. 8. Attach bosses to sidewalls or ribs. Bosses are cylindrical standoffs molded into a plastic part to accept an insert, self-tapping screw, or pin for assembling or mounting parts. The outer diameter of the boss should be 2.5 times the diameter of the screw diameter for self-tapping applications. Bosses shouldn't be freestanding. Always attach bosses to a sidewall or to the floor with ribs or gussets. Their thickness should not exceed 60% of the overall part thickness to minimize visible sink marks on the outside of the part. For example, a part with an outer wall of 3 mm should have internal ribs that are no more than 1.7 mm thick. And last tip, highlight visually important surfaces on your part where there must not be any marks. In order to properly manufacture your part using injection molding, it is important for the manufacturer to understand from the outset what your requirements are in terms of its appearance. One key point for the toolmaker to consider is the gate location. Gates are entry sections through which the molten material enters the mold. The toolmaker has to choose the type of the gates and position them strategically to minimize potential quality issues. Gates also leave gate vestige or a visual indication that the part was gated, even if it is subtle. That's why we recommend letting your supplier know about any aesthetic and functional requirements and define where not to gate. Reliable processes, optimizing part designs for manufacturing, and high-quality mold tooling are crucial for achieving consistently high-quality parts. Xometry will help you source your injection molded parts by providing comprehensive DFM feedback and manufacturing your parts with our vetted production partners. Simply upload your 3D model using our online platform, set the required quantity, materials, color finishes, and other specifications, and submit a quote request. Xometry, where big ideas are built.